Hello, good afternoon, good morning, good evening, depending where you're joining from today. Thank you everyone so much for being here for today's Tech Talk. Just a few quick logistical announcements before we get started, and also hope that you do see that there is a poll open on your screen, and we would really enjoy your feedback on that. And we'll see those results a little bit later in today's presentation. Just so you know, we are recording today's event and will be archived, and you'll be emailed about when that's available. We do hope you can stay for the full event, but if not, you'll be able to view it at a later date. Also, if you need any technical assistance, please use the Q&A. The Q&A is where we're encouraging you to put all your correspondence today, questions for today's panelists, speakers, and also any technical issues you may need to have addressed. I'll be happy to help you troubleshoot there. We do also have live transcription enabled today. You can manage that individually on your own screen by clicking the CC button on Zoom and choosing to either show or hide those subtitles. Once again, if you need anything, please let me know in the Q&A. And I do encourage you to enter those questions throughout today's webinar, and we'll try to get to some of those questions at the end of today for our Q&A. So now I'm happily hand things over to Annice Kim to kick us off. Annice, over to you.
Great. Thanks, Shane. Sorry, just a second. Good afternoon, everyone. Welcome to our Tech Talk. My name is Annice Kim, and I'm a Senior Director of the Center for Communication and Media Impact here at RTI International. I will be serving as your moderator today. This is the 8th webinar in RTI International's Tech Talk webinar series. With the focus on data modernization, the Tech Talk series provides an opportunity to connect with our experts, exchange and share information, integrate solutions, to help better connect, analyze, share, and leverage your data. Next slide, please. With OpenAI's release of ChatGPT last November, the excitement, as well as the doomsday predictions of what generative AI tools like ChatGPT can do, have made their way into news headlines, as seen here, and into our everyday conversations. Next slide. But what exactly is ChatGPT? Chat Generative Pre-trained Transfer is a generative AI chatbot that generates human-like text responses to questions within seconds. How does it do that? It is a type of a large language model, a statistical model that is trained on a lot of text data to predict the next word in a passage. For example, the autocomplete function you use when texting is a type of language model. But an LLM like ChatGPT is just a large, more sophisticated version of that same idea. Though ChatGPT is the most popular of the LLMs out there, they amassed 100 million monthly active users in only 2 months after its launch, making it one of the fastest growing consumer applications in history. It's not the only one. There are many that perform similar functionality, which will increasingly be available for public and commercial use. Shane, can you pull up the poll results from earlier? We asked earlier how many of you are using ChatGPT, and it looks like about 30% of you are using it, 25% of you are considering it, and 40% of you are not using it yet. Thank you. So with the new era of LLM and generative AI tools, we started to think about how can we use these tools to help inform the work that we do in health communication research. Next slide. So during today's webinar, you will hear about the ways that we've been exploring the potential benefits, opportunities, and use cases of generative AI tools for getting communication research insights faster, the strengths and limitations of ChatGPT compared to the gold standard approaches for coding unstructured text and generating plain language summaries, how federal health agencies are approaching the use of generative AI for communication research, and key areas for future research and consideration. Next slide. First, we will hear from Rob Chu, who is a senior research data scientist here at RTI International. Rob will discuss a case study of using ChatGPT for qualitative coding. Then we'll hear from Mario Navarro, lead health scientist at the FDA Center for Tobacco Products. He will discuss how he and his team at CTP have been using LLMs in their work. And then finally, we will hear from Stephanie McInnis, UX researcher here at RTI International. She'll discuss a case study of using ChatGPT to develop plain language summaries of health content. Next slide. Before we begin, a little disclaimer and some of the key elements that I want to highlight. The data entered in generative AI interactions and models will be retained and can be incorporated into the model in the future. The data shared with these products can be linked to individual users. Non-public data should not be entered or made available to third-party websites that have not been approved. Furthermore, it has been shown that generative AI responses can be biased, limited, and misleading. And in that second paragraph, we discuss some of those concerns. And so therefore, the current case studies that we will be discussing in this webinar are exploratory only and should not be used for any other purposes. Next slide. With that, I'll turn it over to Rob Chu for our first presentation on using LLM for qualitative coding.
All right, thanks, Annice. Next slide, please. Okay, so qualitative coding is a popular research method used in health communications research for analyzing text, such as news articles, reports, interview transcripts, and even social media. For example, here on the right is a chapter from the CDC Field Epidemiology Manual that's dedicated to qualitative data analysis, including a whole section on coding. However, though we often find this approach useful and insightful, qualitative coding can be slow, expensive, and error-prone. Next slide, please. Okay, so to make this point clear for audience members who aren't familiar with qualitative coding, I'd like to quickly go through this diagram outlining the steps for a type of qualitative analysis called deductive coding. So in deductive coding, we first develop a categorization scheme based on existing theories and research. This is captured here in the icon 1 in the upper left-hand corner of the diagram. To operationalize these categories, we then developed a codebook with definitions and instructions for how coders should apply these codes when reading documents. This step can actually be pretty tricky since it requires the researcher to make assumptions about a coder's prior knowledge when deciding how detailed to make those code descriptions. Now, in an ideal world, we would then use the codebook. We then use this codebook to code all the documents of interest. However, this is often ill-advised for two reasons. Number one, there are often a lot of documents you're interested in, and needing to read, interpret, and categorize all of them would be very burdensome. And two, just because you create a codebook doesn't mean that others who use it will interpret it the same way, making replicability a concern. Therefore, instead, we usually draw a small random sample of documents and then have multiple people code all of them independently. We then compare the coders' responses to each other and calculate inter-rater reliability, sometimes abbreviated as IRR. So now we're at number 5 in the bottom right-hand corner of this diagram, right? So if the IRR is low and coders can agree on how to code observations, then we're back to the drawing board and we start the process over. However, if agreement is high, we can then draw a larger random sample of documents for final coding. Now, since the agreement is high and it's been determined that coders are categorizing in a similar fashion, we can then split up the documents in the large sample across coders so that each document is only coded once. Lastly, we can calculate summary statistics on the frequency of codes as well as associated confidence intervals. All right, next slide. So then, given how laborious deductive coding could be, our research question of interest is, how well does ChatGPT perform deductive coding compared to humans? And we're going to evaluate this on 2 different dimensions, one being inter-rater reliability, and 2 based on coding time. Next slide, please. To answer this research question, we started by looking for publicly available data sources that include text, coded data, as well as a code book. And surprisingly, this was actually challenging to find many data sets that met this criteria, but we were eventually able to find 4 that represented different types of documents, categories, and coding schemes. Next slide, please. We then developed prompts or instructions to tell ChatGPT what we wanted to do. Here on this slide is an abridged prompt based on what we used in this work. I'll read it aloud, at least the top part, to give you some intuition for how this works. So the prompt starts, you are a qualitative coder who is annotating news stories. To code this text, do the following. First, read the codebook and the text. Next, decide which code is most applicable and explain your reasoning for the coding decision. Finally, print the most applicable code and your reason for the coding decision. And then we tell it to use the following format, where we then insert the coding instructions that we want it to follow, the text of the document that we want it to code, the list of codes that we want it to code, in this case, different topics related to news stories, such as business, entertainment, politics, sports, or tech. And then the model will continue providing text, where that remaining text should be a coding decision, as well as a reason for the coding decision. Next slide, please. Okay, so as some final background before we share results, I wanted to explain how we assess reliability and introduce some terminology that we'll use in the coming slides. So as a first approach, we calculate what we call the human model agreement here on the right, which is the agreement between the original published codes from those publicly available datasets and the codes predicted by ChatGPT. Now, we could have left it there, but we felt there'd be an issue in interpreting the results if the agreement was low. Was it low because ChatGPT was hallucinating and doing a poor job coding, or was it low for the same reason that IRR is often low between human coders, because the codes are vague, poorly defined, or too subtle for people to consistently agree on? That's why we also included a human-human agreement comparison here on the left. This measured the agreement between the original published codes and an independent coding conducted by our team using the available codebooks. Now, if the human model agreement was low, while the human-human agreement was high, we'd know that the low human model agreement could be attributed to a failure of ChatGPT. And so with that background, let's get into some results. Next slide, please. All right, our first major finding was that ChatGPT often coded at levels of agreement comparable to humans. So here in the middle of this table are the human-human and the human model agreement metrics that we talked about just in the prior slide. And as you can see from the rows that are highlighted in green, there are many times when these two values were very close. Next slide, please. However, this wasn't always the case. The rows highlighted in red are categories for which the human model agreement was often far below that of the human-human agreement. While concerning, a silver lining is that we were able to predict when ChatGPT would fail in this way. This is based on what we call the hypothesis test of randomness, where we compare the ChatGPT's code frequencies to that of a random process. And you can see these here in the very last column of the table. If the code frequencies produced by ChatGPT were not able to be distinguished from a random process, then we flagged it as being suspicious, with the possibility that the models may effectively be guessing at random for this code. And maybe an illustrating example of this failure, let's look halfway down the table at the INDV code, which is short for individual. This code was supposed to be assigned if a tweet mentioned any individual person in text, either by name or indirectly. When we looked at ChatGPT's responses for their reasons for coding decisions on these tweets, we saw that ChatGPT was often overassigning the individual's code to tweets that mentioned groups, such as political parties or police departments. Now, its reasoning was that since a group is made up of individual members, that the individual code should then apply. And while I'm pretty certain that wasn't the original researcher's intention for how to code this code, it does illustrate a path for improvement for the model if we were to more explicitly state what counts as an individual in the codebook description. Okay, next slide, please. Lastly, we also compared ChatGPT to human coders based on coding time. And what we found was that ChatGPT was substantially faster than humans at deductive coding, especially for long documents with many categories. A prime example of this is highlighted in the table in blue. So for this, the contrarian claims dataset, it took human coders on average just under 2.5 minutes to code a document, 144 seconds. In contrast, ChatGPT took only 4 seconds per document, meaning that ChatGPT was 36 times faster than our human coders. However, even this is an underestimate, since ChatGPT, remember, includes both the code and a reason for the coding decision, whereas we only ask the humans to provide their coded response. Next slide, please. Overall, we believe our findings have several implications for the future practice of deductive coding and related research. First, based on the reduced coding time, and in many cases, comparable results to human coders, ChatGPT appears promising for deductive coding. Second, using ChatGPT and other large language models for deductive coding likely requires us to rethink how to do deductive coding from the ground up. For one, at the very least, this will require different types of reporting and documentation, such as publishing of prompts and codebooks to support reproducibility and critique. To promote this reporting standard, we provide the prompts, codebooks, and model details for this work online, and I'll also share it in the chat. Lastly, despite these implications, we do not consider ChatGPT as a replacement for qualitative researchers, but rather as a tool to support accelerating the latter stages of deductive coding that tend to be more manually taxing and repetitive for researchers. Next slide, please. To make this more concrete, we proposed a holistic approach to deductive coding using large language models that we have tentatively called LLM-assisted content analysis. Now, instead of developing a codebook alone, you co-develop a codebook with a model like ChatGPT to understand where there are gaps in understanding and interpretation. Additionally, instead of relying just on human iterator reliability, we can also calculate human model iterator reliability like we did in the previous slides. Lastly, the big time saver, instead of manually coding the final large set of documents, these can instead be coded by a large language model like ChatGPT once they are determined that they are valid and reliable. Next slide, please. Now, before going, I did want to include some limitations for our work. First, to match the output of the original data sets, we forced the model to either choose yes or no, or select a single code from a set of mutually exclusive code categories. This meant that we didn't give the model an option to defer or state uncertainty in its decisions, i.e., we did not give it a do not know option. Second, we only assessed ChatGPT for this work and not a wider variety of large language models. So some of the experimental results may differ depending on what downstream model that you use. Lastly, a major limitation of using this approach is also one of the intended benefits. Researchers implementing this approach will inevitably end up reading less documents, which in some cases may actually end up limiting the development of new theory and discovering themes that were not proposed by the research team a priori. We anticipate that future work using large language models to support inductive coding could be a promising approach to help address this final issue. Next slide, please. Finally, if you're interested in learning more about our work, please feel free to check out our preprint. I'll also post this link to the preprint in the chat for easy reference. With that, thank you all for your time. And now I'm going to hand it over to Mario, who's going to talk about actually a very related use case for some of the work he's doing at the FDA.
Thanks, Rob. Let's see. Okay. Hello, I'm Mario Navarro from the Market Intelligence team within the Office of Health Communication and Education at the Center for Tobacco Products within FDA. Today, I really want to talk about our use of large language models, specifically ChatGPT, in qualitative coding, and in a very specific example. Next slide. So here's sort of the overview of the presentation. I want to begin with what I want you to take away, who we are, what are we doing with large language models, and the type of insights we seek to gain from ChatGPT and models such as these. This is just an overview of the methodology we're using, and we hope to see results by the end of the year. So I think the value of this presentation is really to provide insight on how the bread is made for these sort of surveillance analyses, and like really where our mind's at and how we're moving forward. Again, this is just going to be an overview of the methodology and less so any results. We're hoping we're like on the edge of our seats, hoping to see what happens next. But yeah, I hope you take away these things from the presentation. Next slide. All right, so in the current presentation, I would like to answer the following questions. What is the market intelligence team within the Center for Tobacco Products? What are our goals? How do large language models fulfill these goals? What are plans to use these models? What methodologies do we use? Next slide. All right. Okay. The Center for Tobacco Products is a regulatory body that proposes new rules and regulations concerning the tobacco industry. CTP, the Center for Tobacco Products, does sort of four major components. One is reviews tobacco applications. This is within the Office of Science. They write rules and guidances. That's the Office of Regulations. Enforces rules and regulations, Office of Compliance and Enforcement, and then informs the public about harms, which is where our team fits in, which is the Office of Health Communication and Education. So on our team, our role is to really, next slide. Okay, so the market intelligence team is an interdisciplinary team, which is housed within the Division of Research and Evaluation and fulfills the urgent need for monitoring and surveillance of the tobacco product landscape to provide resident messaging. Our team of 4 takes point on surveillance platforms and data set. The team works with a contractor on the market intelligence reports, which is sort of like a capstone of everything that we are doing with social media data. So today I'm going to talk a lot about social media data, which is one of the pillars of our team. Next slide. So today I'm really going to focus on 2 of these 4 goals. But the goals of the market intelligence team are to understand youth, young adult, and current and former users' perceptions, appeal, use of current, new, and emerging tobacco products and their impact, perceptions of CTP messaging, understanding the sentiment of FDA policies and messaging, and their understanding of tobacco industry marketing and advertising tactics and their impact. Again, today I'm just going to really focus on the first 2 and how our methodologies are going to help answer or fulfill these goals and really provide more insight to help us develop better messaging. Next slide. So currently we analyze large amounts of social media posts, from tens of thousands to hundreds of thousands of posts. Keyword searches and subqueries can only provide a limited understanding of the data. We would like to qualitatively code for themes, but we can usually only code for a subset of data. So to really advance more advanced social listening techniques, we try to find ways to analyze data directly than through boxed commercial software, which is very limited in many ways because it's meant for the marketing space and less so for the public health space. So to really enhance our social listening and allow for qualitative coding that would normally be impossible on a scale this large, the solution to the problem is to use large language models, specifically GPT and its chat functionality, to classify and qualitatively code social media data. We're combining older social science techniques with newer data science methodologies to really enhance this work. Next slide. So currently, our work is conducted through university partners and contractors, specifically a lot of our work in regards to social media. Since our team is 4 people, we're a very, very small team. So for GPT, these teams at the university level and these contractors go through an API or application program interface using Python script in Jupyter Notebook to interact with OpenAI's GPT API and repeat the script thousands of times, which would allow for iterative coding. And we wouldn't have to use the interface. It just goes directly through that API. So it can just run the script and then through that interface, just code all the data points that we would like. And just to show you how affordable this to scale this sort of work is the project I'm going to talk today. Outside of labor, but just the actual cost of using GPT was around $30. So it is relatively cheap to code for a large amount of data, which I'm going to talk about in just a second. Next slide. So we have these things called the market intelligence reports, and they really are a capstone for our social media work. And they cover topics of interest to provide surveillance insights using social media data. Current GPT integration when investigating ends products discussion is really what I'm going to cover today. And we've had other market intelligence reports, but we haven't really used GPT before in these. And these reports cover a wide range of tobacco products or a better understanding of specific populations. So the sample is made up of both posts from Twitter or X and Reddit posts using a query made up of e-cigarette keywords. And for those of you who are unaware what a query is, it's just a large string of words that can then pull the data that we specifically want from the API, or sometimes we also use things like Brandwatch or Sprinkler to be able to be more specific and pull all that data that we need. This is just the first step of integrating LLMs in our reports. And so we hope to really advance this and build this iteratively over time as well. So next slide. So our current, I wouldn't say research question, I kind of messed up here. It's really our current question from leadership is, can we focus on stories of e-cigarette users? In other ways, are there ways to identify personal stories regarding e-cigarette experiences? Really, the research question is, what are the types of conversations that are occurring regarding individuals' e-cigarette experiences, specifically on the topics of mental health, vaping cessation behaviors like quitting vaping, and product switching as well. And so we sort of separated these by platform to analyze by platform, as each data point is very different. Like posts are very different on Twitter or X than they are on Reddit. So we really have to look at these analyses sort of in separate subsamples. And the number you see in parentheses is the number of posts that we have to analyze. And so all in all, it's about 60,000. And so to qualitatively code this, that would be impossible or take a very long time to do this by hand. And so we've sort of developed an approach very similar to what Rob has sort of talked about in the last presentation, as well as one that we found from a manuscript that was published earlier this year as a preprint, to really figure out like how to utilize GPT to answer this research question. Next slide. So we have a modified 5-step approach. It comes from Zhao and colleagues that was this year. That was a preprint I had discussed. We have it at the end of our presentation if you're interested. And this methodology is really to allow ChatGPT to qualitatively code this data. So first, we create a code book for each of these themes on these platforms. We develop prompts for ChatGPT using examples. Human coders will then manually label a subsample of 50 posts, as well as GPT coding the same sample. And then Cohen's kappa will then be computed to see what their inter-rater reliability between the human as well as GPT is. And then performance will be assessed, and if adequate, and we have a pretty good Cohen's kappa above 0.75. GPT will be used to analyze the larger sample of posts. In this case, those few thousand, many thousand actually, of those posts. And then we will analyze and report on results separated by personal narratives, because I think looking at that personal narrative, we'll use it almost as a way to separate the types of content that we have, so we know what themes that are emerged through that social media content and know what is being discussed in regards to personal narrative. Next slide. So first, we will set up GPT by providing context and a role for their code. In this case, we'll have GPT code as a social science researcher from the United States. The following example is, again, as mentioned, is regarding vaping cessation. Next slide. We will provide a definition for the code. In this example, the narrative is defined as author's personal experiences with quitting vaping or e-cigarette use, including but not limited to mentions of quitting strategies, tips or tricks, or reports of time since last use of vape products, and does not include mentions which only refer to cigarette smoking or other products. So we're very specific on what this definition is, as well as provide an example, which is in there, which I won't say for timing purposes, but that's the next step. Next slide. We will then give GPT the actual post we would like for it to classify. Again, this is all within the same instance, but we just reiterate this over and over for every post that we would like for it to code. So there's an example post that we have in here, and then this will just change every time. So it can just kind of do the same method over and over and over again until all the data is coded. Next slide. So there's a lot of ethical considerations to consider. And as we are in the FDA, I am very concerned, it keeps me up at night, on how we use these models, because just one misstep can put you in ethical rocky waters. So anything that is processed through ChatGPT is public, and Rob has sort of reiterated that. So we only use public data, specifically public social media data. So if you end up using private data, please make sure that IRB has approved this methodology and that there's absolutely no PII shared. As ChatGPT makes things public, other people can view it, the FDA cannot share any internal or confidential information. So again, personal narrative is something very vague. There's no confidential information, so we're good to go. Some other considerations is there's little known how these models actually draw conclusions. It's still a bit of a black box. And so because of that, we're really unsure how this works. Prompt engineering, or the developing of the prompt, which I had kind of showed you the step-by-step, is still really a new action and will require a bit of work to figure out what prompts are most effective for these tasks. And finally, LLMs are not a replacement for supervised learning models, which can be trained to do certain tasks, such as qualitatively code. But I think for more of rapid turnaround analyses, or to have things that require more nuance, LLMs will be very helpful. Next slide. As mentioned previously, this is just one component of our analyses. Very specific context of an individual's mental health journey. This methodology still needs to be tailored for each individual context and for your own research purposes. Next slide. Thanks everyone for your time. Looking forward to your questions. Now I will turn it over to Stephanie and her presentation on LLMs for developing plain language. Thanks everyone.
Thanks, Mario. Great. So hi, everyone. As mentioned, I'm going to discuss today how our team experimented with large language models to help develop plain language content. Next slide. So in our case study, we experimented specifically with ChatGPT to adapt health content into plain language. The types of materials that we experimented with included web pages, technical reports, manuscripts, and consent forms. We purposely gathered diverse documents in hopes of exploring multiple use cases. For example, web pages were much shorter than manuscripts, while manuscripts and technical reports introduced more highly technical information. We then developed a ChatGPT prompt that we found to be effective after some quick iteration. And then after running the prompt on the materials, we evaluated ChatGPT's outputs according to multiple measures. Next slide. So in this experiment, we really wanted to better understand if ChatGPT can help develop plain language content. In addition, what are the opportunities and limitations for using ChatGPT to develop plain language content? And then finally, what areas should future research explore? And given some of our assumptions, we were particularly interested in plain language principles like formatting and finding alternatives for technical and scientific terminology. But before jumping further into our case study and breaking down all the steps, I want to share a little bit more about plain language in health communication. Next slide. So today we know that almost 130 million adults in the US read at or below a 6th grade reading level. And individuals with low literacy are 4 times more likely to report their health status as poor or fair. So ultimately, health literacy is linked to health disparities and increased costs. So this is particularly important for our work as health communicators, as we're often developing content for populations in the US or specific audiences within the US. Next slide. So what is plain language exactly? It is a strategic response to reduce the complexity of information and improve health literacy. It is often defined as a way of writing that is understandable on the first read. So this includes not only the language used, but also the formatting, organization, and layout of the content. So plain language is not writing in a condescending tone or neglecting accuracy. Rather, plain language is writing for clarity and meaning. It is user-friendly, and it addresses the reader's interest and need with accurate and reliable information. Next slide. So over time, a significant body of research and practice guidelines have emerged. In 2010, the Plain Language Writing Act was signed. Clear government communication that the public can that frequently work with federal agencies. We really have a responsibility to ensure content we create is plain language. So at RTI, we have plain language experts and skilled staff that create plain language content. But developing these materials requires knowledge and skills to achieve reader-friendly writing and accessible design. So really, because this is a priority as health communicators and to our clients, we're constantly looking for ways to improve our work and also increase efficiencies. Next slide. So this is where generative AI comes into play. Developing plain language content can be very time consuming and requires specific skills. And so as you all have heard a little bit about ChatGPT in the previous 2 presentations, we also experimented with ChatGPT in this context as well to develop plain language content. And next slide. So we started by developing our prompt. For the experiment, we used the following structure that you see on the slide. First, we described the task and key elements for ChatGPT. So this included that this was telling ChatGPT we were going to include original text to rewrite. We were going to provide an intended audience, and communication principles to follow. Then we described the intended audience. This did include an approximate reading level for additional clarity. We do realize there are some issues with defining a reading level, but we felt this detail would be helpful in this context. And then next, we put in the original text we wanted ChatGPT to adapt. And lastly, provided clear communication principles to follow. Many of the principles we included in this list can be found in CDC's Clear Communication Index. Just for an example, we did ask ChatGPT to put the main message of the content at the very beginning and to bold that main message. And then after we ran the prompt with the materials, we evaluated the outputs. Next slide. Our evaluation measures are listed here on the slide. The use of CDC's Clear Communication Index was to ensure we used a research-based tool in our evaluation. All reviewers are trained in plain language, although the evaluator assessed items you see here are subjective to the reviewer. The other measures you see on the right side of the screen are mathematically calculated readability formulas. So this does use a mathematic calculation, usually based on word and sentence length, to calculate what school grade level content is written in. We included all of these measures really in hopes of having a comprehensive evaluation process that would take a lot into consideration. And then once we evaluated the materials, we identified key themes and items that addressed our research questions. So to get into some of the results on the next slide, we have first some general observations. So these are just a few things we want to note kind of overall. First is that we asked ChatGPT to use markdown formatting. So this is denoted by symbols within the content. This is just something to keep in mind if you're using something like ChatGPT and requesting specific formatting specifications. It isn't going to provide, a Word document like formatting when in the output. In general, some adaptations we did find were too brief and therefore incomplete. Some of the information that was removed did have important meaning. There were also some areas of inconsistency across the documents, although the prompt did not change. There were also a few instances of stigmatizing language. Often this language was in the original document, so it wasn't developed, but rather it just wasn't changed by ChatGPT. There were also some areas where we found ChatGPT did not demonstrate proficiency in finding alternatives for really highly technical terms or phrases. If those technical terms were in the original documents, sometimes we did see them in the output as well. Along with that, some of the complex terms were not defined. Again, ChatGPT was pretty good at not adding new information, so the definitions that were included were also in the original documents. And then lastly, we did find that reading level decreased in almost all of the materials from comparing the original to the ChatGPT output. So to break this down a little bit more, I'm going to go through some findings based on the document type. I'm going to talk through the website and manuscript tests today. I'm also happy to answer questions during the Q&A portion about our tests with the technical reports and consent forms. Next slide. So overall, website content we found was chunked and sectioned appropriately. So there were some section titles that were a bit confusing, but overall the organization of the content was done well. We did also find, as mentioned earlier, that some content was removed from the original version that occasionally resulted in incomplete information. So one example was that we did have a web page that had COVID-19 treatment options listed, and one of the treatments was left out of the ChatGPT output. So in this scenario, the reader would not have the complete information. We also found that some terminology used was a bit confusing. An example you see here on the slide was that healthcare facility was a phrase used in the original document, and that was changed to healthcare place. So although place is plain language, this isn't a phrase we would commonly hear in everyday language, and therefore maybe not the best fit here. There were also some instances of stigmatizing language, as I mentioned. In particular, there was the use of the term obese, which was in the original document, but due to nuances like who the intended audience might be for this material, another term could have been better. And there were also some areas where gender neutral terms could have been used and were not. Next slide. So I wanted to provide an example for you all of what the ChatGPT output would look like. As you can see, the different symbols denoting some of the formatting. The main message and title are in line with the content of this page. However, there are still some more technical terms or conditions in that box you see that were not defined. But overall, this output did seem to work well. Next slide. So moving on to the manuscripts, overall, we found that plain language adaptations of manuscripts they were pretty on target. However, usually the methods and analysis information was omitted from the ChatGPT outputs. So there also were some instances of confusing interpretations of some technical terms. For example, one manuscript was discussing COVID-19. And both of the phrases you see on the screen, after recovering from COVID-19 and after the acute phase of COVID-19 were both used. And this is slightly confusing to have in the same summary, especially because of the nuances between COVID-19 symptoms and long COVID symptoms and experiences. So this was one area where the technical kind of interpretation could have been a bit better. Next slide. Here's an example of what a plain language summary looked like from ChatGPT. As you can see, this started with the title and kind of key points bulleted out for the reader, and then a section about the study, a section for findings, and then lastly for the conclusion. Next slide. So overall, we found that strengths of using ChatGPT as a tool to really getting started on creating plain language content is that it was particularly good at condensing large amounts of information and content quickly. It was good at chunking and sectioning content out appropriately, maintaining the meaning of the original content. It did avoid adding any new content, and also using active voice. Some weaknesses we found were inconsistent use of inclusive language, omitting sometimes too much information in a plain language version, finding alternatives to and defining medical and healthcare terminology, interpreting the content overall and some of those nuances of the topic, and then lastly, consistency. We do wonder if some of the weaknesses could be addressed with updates to the prompt. For example, we do feel that potentially adding more details to the prompt about inclusive language could address that first issue, although we haven't done this yet and included this in an experiment. Next slide. So this really just brings us to some important considerations about using ChatGPT. As previously mentioned by Mario and Rob, all of the information we use was publicly available, but therefore we didn't need substantial tone or style changes. So it's unclear how ChatGPT could adapt tone and style of content. Also, ChatGPT does have a maximum of about 4,000 characters for and content you put in via the user interface. We did access ChatGPT via the API because it allows closer to 8,000 characters. So this is just a consideration if you're thinking of using this for something like a manuscript or other documents that are quite long. And then lastly, ChatGPT cannot interpret images and figures in its current version. So this is also a consideration if you're looking to use this in a situation where images or figures are included and communicate meaning to readers. Next slide. Some limitations to our experiment that I just want to highlight are that the reviewers are trained in plain language, but there were multiple reviewers for our evaluation. Our prompts also did not specify the length of the outputs or requested a specific length, and others could consider specifying this in your prompt. We know ChatGPT isn't always great at providing the requested length, but this may help with some of the issues of omitting too much content in plain language versions. We also did not include another iteration of testing with an updated prompt, although we do have a few areas, as mentioned in this presentation, of where we think that may help. And we also did not conduct testing with the intended audience to assess how outputs resonate with them. Next slide. So there's certainly more research to be done. I think this experiment highlights how multiple iterations of testing with prompts and really ideating on that a bit more is needed to better understand when and why inconsistencies occur. Also adjusting the prompt to better serve some specific plain language needs, like inclusive language, for example, could be a great area to explore. And then lastly, research with intended audiences to better understand how some of this adapted content does resonate with them. But ultimately, large language models are constantly evolving and changing. So just ongoing research too to keep a pulse on these changes is needed. Lastly, on our next slide, we have just kind of the use case that we want to present today is that ChatGPT can be a tool to help get you started on working like a first draft of plain language content. But beyond that, plain language writing really still requires human interpretation, review, and updating for accuracy, inclusivity, and nuance. So definitely still something that humans need to be doing, although, it's exciting to see where ChatGPT can help us. Thank you so much. That's the end of my section, and I'll hand it back over to you, Annice.
Great. Thank you, Stephanie, Mario, and Rob, for your really exciting presentations and already thinking about some of the common themes that have been coming up. Before we jump into our Q&A session, please note that all registered attendees will receive an email in the next few days with links to view the recording and download the slides from today's presentation. And also, if you're willing to share in the chat, would love to hear about folks who are using LLMs or ChatGPT, what topic or what issue you're using it for, because it sounds like there are quite a bit of folks who are already using it or interested in using it. So if you're willing to share, please put that in the chat. And with that, I'm going to head over to the Q&A section. There were several questions that were already answered, so I'm not going to go over those. I will start with the questions that are still open. So I'll start from the top. There's a question from Vikram Gulati. Apologies for my pronunciation of all of your names. This question is around using RAG technique to point LLM to specific knowledge bases. Rob or others on the panel, is this a question that one of you would like to respond to?
I can respond to that. For those of you who aren't familiar, RAG is an acronym for, I believe, Retrieval Augmented, what's the G? Generate, I think generation or generative or something like that. Basically, it's the use of creating text embeddings out of from having a sets of documents and be able to use a large language model to search within those documents for certain things and do question and answering. Very useful for certain use cases. None of the problems that we outlined probably align with that, though we have at least internally looked at it for some kind of technical assistance on technical documents. For example, like we help. We have a contract with CMS on a large like payment model, or like an insurance payment model, and it's the details of it are like very complicated, and there's like technical specs online about it, but obviously like people are still very confused about like what things mean and like how to interpret it. And so usually when we provide technical assistance, people just ask us questions about it, and then when we try to talk with them and send them answers and replies to it. So the alternative was like maybe we can use like a RAG-based system where we could ask a large language model questions about our particular documents, these technical documents and specs, and see if it could answer some of the questions that we've got in the past. And the results were pretty encouraging. I mean, obviously they weren't perfect, but like I think like, let me see, I think I actually have a slide somewhere here about this that has some numbers. Yeah, so at least in their evaluation, about 78% of the answers that were returned by the large language model were usable as a first draft, which is pretty cool. And what's nice about that is also that it usually returns the exact portion of the documents that it's referencing. So it's good to be able to check, and it's a convenient way to see if what it's saying makes a lot of sense because you have the original text right there.
Great. Thanks, Rob. We're going to go on to the next question from Timothy Barzik. How effectively or easily could ChatGPT be used to then build a relational database of information? If table keys and variables were already defined, could GPT effectively scour the literature and populate the tables automatically?
I could try answering that again. Maybe it's yeah, I really like this question. I think you could maybe do part of it. I'm not sure end to end like how well it would work, or like if you'd want to trust it. But if you, maybe one way of doing this, if you really did want to, I think each of the entries in the table of your database that you're interested in would need to be something that would exist out in the literature and that had something to, related to it. Like if you're making a database on the scientific literature for maybe like a systematic review, for example, I could see that in each row is a different paper. I could see that totally being something that potentially you could help populate. If you, it'd be kind of a two-step process. You'd have to find the papers that were appropriate for that table, and then you'd have to be able to extract the information from the papers that you'd want to populate in that table for each paper. But both of those steps you could at least get partially through, maybe with large language models, maybe using like RAG or some other information retrieval method to first find the papers of interest, to figure out what rows should belong in that table, and then using information extraction on the individual documents and saying, what are the things that I want to pull out that represent the columns of interest, and see if I can get that from each paper. We have some success on the former stuff for information extraction, actually for systematic reviews that we're hoping to publish soon. And it's so far it's actually looked pretty good. So only done with open access articles, which is maybe the next question here, but we'll get to that in the next one. And I'm sorry, I'm dominating all the A's and the Q&A's.
That's okay.
Here.
That's okay. Thanks, Rob. So I want to be mindful of time. There are still questions in the Q&A, and we will do our best to reach back out to the individuals who asked the questions, since we did not have enough time to get to all of them. But I just wanted to take the time to thank all of you for attending today's webinar, thank the presenters, If you have any questions, please reach out to us. We would love to hear more about what you're working on. Apologies that the chat was not enabled. Just as a final reminder, today's presentation was the 8th in RTI International's Tech Talk webinar series, focused on data modernization solutions. Please check out www.rti.org for more information and to register for upcoming webinars. Thank you.